Guys, we're going to learn about SAP-1 programming. Basically, before going through this problem, you need to have basic idea about SAP-1 architecture. And SAP-1 architecture basically contains a program counter, RAM, memory address register, controller, sequencer, accumulator A, base register B, and you have adder and subtractor, and you have out. So without knowing these things, it will be very difficult to understand what is going on inside of it. However, I'm assuming that all of you know, before going to this problem, all of you know what is SAP-1 and its architecture. So inside of SAP-1 you have a RAM. All of you know that you have a RAM, and whatever the instruction we're going to write is going to be saved inside of your RAM, all the instructions and all the data. So here the question is, write a code for the following arithmetic problem in assembly language for SAP-1 architecture and translate into equivalent machine language code using the opcodes in table. So these are the instructions you have in SAP-1, and for the each instruction opcodes are given, and we're going to write this one. Basically we're going to perform this arithmetic operation inside of your SAP-1. So the first thing we can do is, as you know, we have to write the instruction inside of your RAM. That means we have to write the assembly language. So all assembly languages will be saved inside of your RAM. That means all the instruction is going to be saved inside of your RAM, and as well as data. So the first thing is, we know that your RAM is 16 into 4. That means it does have 16 locations, and you have 4 bits. You can see 4 bits. So here I'm writing the locations total your RAM has. That means SAP-1 RAM has. So it should be 0 to 15. That means 0 to F in hexadecimal. So 0 1 2 3 4, write it in capital, 5 6 7 8 9, A H, which is basically 10, B H, which is, C H, D H, E H, and F H. So this is basically your addresses of RAM addresses, which does have 16 location, and each here 0 means 4 bits of 0, 1 means 0001. So you know all of this. So here we're going to put all of our instructions. So the first thing what you have to do, basically, here, look at here we have to use 21H. That means at first thing we have to load the accumulator with 21H, and after loading the accumulator we're going to subtract 2H from your accumulator value, which is 21H. Then again we're going to add all this result. That means 21H minus 0 to H, then we're going to add 0AH. That means the first instruction should be loading the accumulator. So without loading anything you cannot wire, because your during addition your SAP-1 work with your addition. Your SAP-1 always works like this: a is equal to a plus b. That means you need to have b register value. So after giving your add instruction, your B register will be loaded with the data automatically, but at first you have to load your accumulator data. That's why you have LDA, that means load the accumulator. And for subtraction you have equation something like this: a is equal to, which is a is equal to a minus b. That means in both of the cases you have to use accumulator and B register for addition and subtraction. But before going through these programs, at first you have to load your accumulator. That's why the first program is LDA. So you have to load your accumulator with 21H, the first value. So if we want to load these things, let's write the program, which is LDA. So here we are going to write, we have to load these things with your 21H, but you cannot write here 21H because this is data. So here you can write only addresses. So at that point, for instance, I'm going to save my 21H at 8H, and you can select any one of the addresses. So this is 8H, so here we have put this 21H, this one, at 8H location. So this is my 8H location, and here I'm going to write my 21H. So your accumulator is now loaded with this 21H. Now you have to subtract 0 to H. So at 1H you can write your subtract. You can choose any one of this, any one of the locations. So here we're going to subtract, which is subtract 0 to, but you cannot write 0 to, so you have to use another address and you have to refer the address. So here we can save our 0 to H into 9H location, and at 9H location we're going to write our 0 to H. That means at 9H location we are saving, we're putting our 0 to H data, and then we have to add 0AH again. So we have to write here add. So you can write here add. So let's write add what? Add 0AH. So I can take AH, I can take BH, you can take any one of them, you can save anywhere. So I am taking BH. So at BH you have to have the value of 0AH, which you are going to add with which you are going to add rest of them, rest of the equation. So you have to have 0H. So at BH we have saved 0H. So this is your machine language, sorry, this is your assembly language, and you have to show this data. That means whenever you are going to put out, the values of accumulator will be shown, and all the data, so whenever whatever you are doing basically saved in accumulator according to these equations. You can see when you are adding a is equal to a plus b, that means after addition the data is going to be saved into accumulator. Again, when you are going to subtract, the data is going to be saved into your accumulator. That means you have to show the value of accumulator to the output if you want to show the output. So here you have to have instruction which is out to show the equations, and to stop the program you have to write halt. All of you know this. So you have only 5 instructions in your SAP-1. So this is total instruction we have. So this is basically your assembly language. So now we have to put the machine language. So machine language means basically binary or opcode. So what is the opcode of your LDA? Basically it's given here, which is 1011. So you can write here basically 1011. And what is the opcode of 8H? So opcode means binary of 8H. What is 8H? 1000. This is your 8H. So this is your opcode or machine code. And then you can write opcode for 9H. 9H means sub. So what is your sub? So this is 1101, and your opcode must be this, your sub 1101, and your opcode must be 9H, which is 1001. This is your 9H. And for this one you should write add. For add, you can see for add what is this. Okay, this is okay, we have done wrong. This is not for add. So this is for, we have to write for sub. So what is sub? Basically 1101. This is for sub. You can see this one is for sub. Last time we did wrong. So this is for subtract. So this is 101, and you have 98, which is 1001. And then you have add, and add. For add you have, what do you have? Add. For add, you have 0110. 0110. And pH is 1 0. So what is B? Basically 11. So 1011. And what is out? So in, for out you do not have any kind of address, because this is just out. So but out you have of course 0001, and you do not have any address, so you can write X. And for halt you have same thing, so which is 1111 from this table. and you have x because you do not have any address. So what it should the binary of this, these are the machine code for this. 21 is for true, it is 0010, and for 1 is 000, sorry, 1. So this is your opcode or machine code for 021 each. Now this is 02 each, which should be 0000 and 0010. And for 0AH it should be, for 0AH it should be 0000 and 1010. So basically this is your answer of this question, which has been problem for different students. Write a code for the arithmetic operation. So this is your basically assembly code, this is your assembly, and this is your machine code or opcode. So this is your machine code, you can write it machine code. So this is your machine code and this is your assembly code. So that's it about this programming of arithmetic operation. Write it into assembly and machine. All the best for exam and other things. So goodbye until I come with the next lecture.